Okay. Yeah, so I'm going to show you actually at the end of Rimple's presentation, he was talking about the application in the Appalachian region. So that's what I'm going to show here for a case study. I should point out that this, the heuristic SSRS is still under development. So it's not yet up on our GitHub, although I expect that will be ready by summer. But what I wanted to show is, a similar case study to what Rimple showed. Our work is largely, our project is largely based, in Wyoming, with the concern about eagle fatalities and so forth in the West. But we want to develop tools that are widely, are generally applicable to other regions. And this case study will just sort of illustrate that, how a predictive model like this could inform us in terms of what are risky conditions for an existing site, or if there's additional new sites being proposed, where might we place turbines and minimize potential risk. So this just a little bit of background, that we have a population of roughly 5,000 golden eagles in the eastern United States, and they migrate from mostly breed in Quebec, migrate down through the Appalachian corridor primarily. And the particular region in southwestern Pennsylvania, West Virginia, is an area where there's been quite a bit of development. It's some of the highest high altitude area in the east, and undoubtedly as we scale up these turbines to larger sizes and the costs keep dropping, and I'm sure there's going to be additional developments in this region. So it's an important region to be able to study and apply these tools in. And I just, an aside, our cover picture on the very first slide of the morning was a picture I took right in the middle of this region. So that's the New Creek wind farm in the background. So so this is the area in particular of interest. It's a sort of a hot spot for golden eagle activity, and these two wind farms are ones that Rimple just hit on at the end of his presentation. This is the Mount Storm Ned Power site. It's a large site along the Allegheny front, and these are 2 megawatt turbines along about 20 kilometers of this terrain feature here. And then directly adjacent on the next ridge east is where the New Creek wind farm is. A little bit smaller wind farm, but it's located along this narrow ridge line. And what I'm just going to simulate here is fall migration through this region. I should point out, though, that there are a lot of golden eagles that winter in this area. So we also, somebody asked a really good question earlier about local movements. And so that's another thing that we'll be interested in simulating in this region, because there are a lot of winter eagles in the area. So the wind rose looks like this. As much of the Northeast, we have a prevailing west northwest flow. So we would hope that under those conditions, when most of the power is generated, we have relatively low risk to eagles in the area. So I'm going to just throw a few simulations here and look at the presence map under different atmospheric conditions. So just a little bit more about the terrain. So this is a highly structured terrain, as opposed to sort of random hills and so forth that we have in Wyoming. This is highly structured northeast to southwest. You notice that the number of the turbines at the Mount Storm Ned Power site are very close to the edge of this abrupt escarpment here. This is the Allegheny front. Here it extends all the way up into Pennsylvania. And then these other ones, the New Creek wind farm is located on a relatively narrow ridge just east of that. So these are both, in terms of migrating eagles, these are what we call leading lines. These are ridge lines that extend for some distance that form a nice sort of pathway for migration. So because of this structure, we would expect, without even running a simulation, that wind direction, if the birds are using orographic lift, wind direction should have a pretty strong influence on where the birds are moving. So well, I'm just going to show you these relative presence maps. So for a couple of different wind cases here. So rather than showing you all of the details, so for a northwest wind, this is a fairly strong northwest wind and weak thermal conditions. So, it might be like you can imagine a day in November that's cold and windy and there's not a lot of sunshine. Birds are likely to be using orographic lift. And what we see, so this northwest wind corresponds fairly well to the predominant wind flow in that area. So we see in that case, really not much conflict with the larger Mount Storm site up on the Allegheny front, but a little bit of potential conflict with some of the turbines at the Ned Creek site, or I'm sorry, the New Creek site. Now, when we switch over to southeast winds, which are a relatively rare wind condition, which is a good thing, because that's when we see a lot of conflict here, potential conflict, where birds are likely moving along this Allegheny front, this escarpment, and passing, in some cases, fairly close to these turbines. So this would give an idea that those kind of conditions are the ones where we might want to potentially, if there is a problem, you could feather back some turbine blades and cut operations. Now, notice that southeast wind is not a very common wind. So if you had to reduce risk by doing some operational adjustments, it likely wouldn't cut into the bottom line too much in that case. For southeast winds, we see maybe a little bit of potential conflict for the other site, but not as much. And this, again, this is southward flow. So like fall migration simulations. When I look at other wind directions, southwest, which is not a particularly common direction, really no conflict at all. The tracks tend to be away from those features where the turbines are located. West wind, which is a more common wind, not much conflict up on the Allegheny front, but some potential conflict for the New Creek site. I should, point out here that these relative presence maps are really, we can think of them as potential risks, but they're not actual risk until we encode some or incorporate into the model some avoidance behaviors and so forth that we will hopefully be able to gather from the work that's being done at the top of the world site and all that data analysis that's underway. Until we encode some avoidance behaviors into the model, we can't really have not much to say about, that difference between potential risk and actual risk. So now I move here to mixed conditions where we have some thermal presence and some orographic as well. I plotted some of those tracks here. Again, it's similar to the westerly. This is a westerly wind. It's similar as before. We have some potential at this New Creek site, but not really any problem at the Mount Storm site. And let's see. So lastly, I have under strong thermal conditions. And remember, this presence map that I'm showing is weighted towards low altitude flight. So in the case of strong thermal conditions and weak orographic lift, so there's only 3 meters per second of west wind here, but we have some good thermal development. We really don't see any conflict near the wind farm in those cases. So that's one particular realization of the thermal updraft field, a different realization, but the effect on the tracks and the presence is minor. And so again, under thermal dominant conditions, we don't see a lot of potential for conflict or risk with eagles in this region. Again, I think I mentioned this in my earlier portion, but the plan is to basically aggregate the results over multiple realizations of these thermal fields, because the thermal field is dynamic. The locations are going to change over time. The strength may change over time. There's going to be some propensity for thermals to form at certain areas, as Regis talked about, depending on things like albedo and heat flux and so forth, incidence angles with the sun. But there's still going to be a strong random component. So the plan will be to aggregate the presence map over a number of realizations of the thermal field. And that's pretty much it. So I hope I showed that the tool can be used to elucidate some higher potential risk locations and wind conditions. So that could certainly help in siting or understanding what's happening at existing wind farms. And as we saw here, wind direction and conditions strongly influence potential risk. And there was a definite difference between these two wind farms in terms of potential conflict with migratory eagles. And that's pretty much it. As I mentioned before, we're hoping to get this thing through some more testing and development and to have it up for you to download later this year, probably summer.